This video will demonstrate how we can modify trip departure time distributions for specific locations in our study area. First, just for context, we're going to revisit the global parameter setting that the local parameter adjustment that we're about to make is deviating from. So we'll visit the project settings in the Simulation tab, go to Input, select the OD matrix, which is the demand source for this scenario, and go to Trip Table Settings. So in a previous step, we decided that the time distribution setting would be curve-based. And in the Curve tab, we entered some specific percentages that correspond to each of the 4 time intervals shown here. And those percentages were based on an assumed peak hour factor that we got from the highway capacity manual. Sometimes you may have locations where you observe distributions of traffic volume over time that differ enough from the rest of the network to warrant their own temporal distribution curves. In those cases, you can apply a local loading distribution specific to that location. So we're just going to make up a hypothetical scenario for this example, and we're going to assume that the count stations that are located on these 2 on-ramps adjacent to Broadway are displaying completely separate trip distribution percentages. The global curve set percentages show a somewhat front-loaded distribution where the second interval has the highest percentage. So perhaps, for example, these 2 count stations are showing backloaded distributions, or maybe the 3rd and 4th intervals have very high percentages. So to adjust for this and apply it to our network, first we go to Tools, Local Loading Parameters, and select Edit Distributions. Go down to Trip Departure Time Distributions, and initially all we have is the default distribution, and this just says that for all times when we run simulations, the scaling factor is 1 or unadjusted. So we want to create our own and select Add, and we'll name it Broadway, so we can remember that this is the location it corresponds to. And we'll add 3 more rows, so we have 4 time intervals here, and then we need to specify the start time for each of those. So since we have 4 in those settings, we'll use 4 here as well. And then the one difference is that these are actually entered on the basis of a scaling factor. And there's a note to remind you of that here at the bottom that says if, for example, the unadjusted percentage for each 15-minute interval is 25%, so if traffic is evenly distributed, we're comparing our proposed adjusted percentages to that base 25%. So we're just going to make up a few percentages here, and so we'll make it so that it's backloaded, and we'll assume 10%, so 10% divided by 25 would be 0.4. We'll set the second to 1, so this will be 25%. And for the last 2, let's say 30 and 35%, so higher percentages than what we have as the global setting. So we'll enter 1.2, 1.4. So now we've defined a new distribution, and it will save in the parameters, and then we'll go back to Tools, back to Local Loading Parameters, and now we'll apply the distribution. In this network, the boundaries of the network where the traffic is being loaded or entering the simulation are at nodes. We're not using centroids, so we want to make sure we're picking the right field here, or the right layer to add the field. And we'll just accept this name it gives us for specifying our distribution, and accept. We can go ahead and apply this to all scenarios as well. And now we'll open the nodes layer, set this to the working layer, and actually instead of opening the data view and trying to find these two specific nodes in the list, we'll just directly query them on the map since they happen to be right here next to one another. So we'll click node 112 and then hold the shift key and select node 111. So now we'll see both of them here. So now we see the new field or attribute that was added as the last row, and when we go to the drop down menu here, we'll see the new distribution we just added. So select that for both. So for a bigger picture context, if we opened the data view, we should see for this last attribute we just added, all of the other nodes should be blank, and that means they will follow the global curve percentages with the exception of these two. So these will follow the distribution that we just specified.